welcome at today's webinar about the application from Tecrum called the Easy Grinder. It is a robotic grinding solution that replaces the manual finishing of metal components. What is monotonous and physically demanding work if not automated? This solution includes the ABB ERB 6700 robots, which are equipped with machine vision technology that can recognize and process different parts without human intervention and or programming. But let's start with introducing myself. My name is Mindel van Gijzel and I'm your host of today. And next to me are our guests of today. And these are Frans Tollenaar and Roland Tollenaar, both CEO of Tecrum. We also have in the studio Martin Visser, who is a specialist from ABB Robotics. The aim of today is to answer as many questions as possible about the Easy Grinder, of course. You might have seen the videos online from our end customer, Ancofer and Liebherr. You can ask all the questions in the chat and we will try to answer them all during the 45 minutes webinar. As it might take some time for the questions to come in, we will start with showing the videos from the Easy Grinder application at Ancofer and Liebherr. Before we start with the questions for our guest today, I have a question for you. So let's start with a poll question. It pops up in your screen. And the question is, how familiar are you with robotic grinding solutions? A, very familiar. B, somewhat familiar. Or not familiar at all. Please fill in your answer. And in the meanwhile, we will start with the interview. And Frans, let me start with you, because what inspired you to begin developing the Easy Grinder? Was there a specific need in the market that Tecrum identified?
First of all, Mindel, let me thank you for having us. ABB has a lot of prestigious customers, so we're proud to be here. And regarding the Easy Grinder, or let's say our robotic solutions, Roland and I own metalworking job shops. And a few years ago, we couldn't find robots which were suitable to our application. So we need robots which can pick parts up from pallets, just like a human can. Or we need robots which can grind parts, just like a human can, which can react to what they see. So you need a vision system. We couldn't find anything like that. So we invented something like that, or Roland did. And from that, actually, we developed the technology for ourselves. And obviously the technology is expensive to develop, so we only did it because we saw a big opportunity. There are a lot of metalworking job shops, there are a lot of OEMs who have this challenge, and we think we have very good solutions for those applications.
Yeah, so you actually started with your own problems and developed a standard solution that can help a lot of different companies in the market.
Yeah.
Okay, good to know. In the meanwhile, we'll see the answers of the poll question coming in. So we see that 29% is very familiar, 50% is somewhat familiar with a robotic grinding solution, and 21% is not familiar at all. So I think it's a good webinar because we're going to explain a lot about robotic automation and grinding solutions. So Roland, can you please explain me why deburring and grinding are important in modern manufacturing, and especially in the industries like metalworking and automotive?
Okay, good question. You see, as long as man has been working metal, man has been creating burrs on metal due to the nature of the material. One would have expected, of course, that in modern times with modern processing technologies that the burrs become less. This is not
happened. In fact, they have in many cases become more. And certainly if you look at modern technologies like high-power fiber laser, if you want to run at high speeds with nitrogen, you end up with very large, vicious, hard burrs.
I would love high-power laser.
Precisely. So in fact, the problem has actually just become worse in modern times rather than diminished. At the same time, however, the quality demands on end products have increased, especially in Europe and also in America to some extent. That is also becoming somewhat more critical of the quality of metal parts, especially also when it comes to coatings, the coating layers and the adhesion of the coating to edges. The demands on deburring are becoming higher from that regard as well. So on the one hand, you've got the processes still creating quite a lot of burrs, and on the other hand, you've got the higher quality demands, and the consequence is that the problem in industry has actually grown rather than become smaller.
So automation is a very important part then, because you can have more control of your quality.
Precisely.
But maybe we come back to that later. And Frans, you told me up front that the Easy Eye 3D vision system Techron developed is a very key part of the Easy Grinder. Can you explain us why it's so important?
It's absolutely a key part, and in fact we use two types of vision in the Easy Grinder. So we have the Easy Eye, which is our in-house 3D vision system, where we use a laser and a camera with a high optical zoom to give us vision at a distance. And we also use 3D vision in the gripper to scan parts, and that's for looking up close and getting details of parts or part stacks. We use both. Both are very important to us and essential to being flexible and offering flexible automation solutions which you don't need to program.
I can imagine that it's a very important part of the automation process. In the meanwhile, let's see if we have some questions from the chat. There is a technical question. How is the risk of grinder kickbacks mitigated, and is it extraction? And maybe we have to come back to that, and let's ask the people in the chat to maybe specify it a bit, because I don't really understand the question. And let's do the second one. How is extraction of the grinder dust handled? So how is the extraction of the grinder dust? How is that handled in your application standards?
Okay, that's a question we get a lot. And especially because people are used to, let's say, throughput deburring machines, which generate a lot of dust and have filtration systems for that. We use a chisel to start off with, so we get rid of a lot of material, the slag and the big burrs with a chisel. So you don't have any dust there. And secondly, we use the grinder exactly there where it's needed. So we don't really generate a lot of dust in comparison to throughput deburring machines.
Certainly not more than what the man normally does with his grinder, maybe even less as a consequence of the chiseling beforehand.
Yeah, because a man has more force maybe on certain parts than a robot does, right?
Yes, for example, yeah.
Yeah.
So it's not something we've got a solution for. It's also not a big problem.
Yeah. And then we have another question. Interesting to learn very complex casting. How can this technology be used? Casting that weigh as much as 2,000 kilos and have lots of small areas that need to remove fleshing, etc.
This is castings. So, currently we're not really focusing on castings as much as we are on plate metal parts. In the future, we will probably do a lot more with castings. So, I mean, the technology and everything around the technology is suitable in a way, but our software has not focused on that yet.
Yeah, so to get back to the person who asked that question, we'd be really interested in looking at the application, but it's not something where we can offer a out-of-the-box solution yet.
No, not a standard solution like the Easy Grinder.
We do get the question often, however, so we know that it exists and we know that it's something that's in the pipeline.
Yeah, so it would be good to be in contact with the person who asked the question. So maybe they can reach out to us and ask the question in person to you later on. Then we have a next question. Deburring is usually a very manual and labor-intensive task. How does TechProm's solution automate this process, and what are the key benefits that it offers manufacturers?
Well, one of the benefits is already hidden in the question, and that is that manual task is no longer necessary. So in other words, that physical and onerous job that is also not always necessarily very healthy is no longer something that's required to be done by a human. And then subsequently the advantages follow. The efficiency is higher in regards of speed, so the robot has a higher throughput in terms of parts generally than what the human can do, because the robot is simply consistent in what it does, doesn't stop, doesn't go for coffee, etc. And thus you've got a saving in terms of in terms of speed. You've then got the saving in terms of man hour, because the man's freed up to do something completely different. But one of the biggest advantages there is the savings in supervision intensity. We found many of our customers say that one of the nice things about the Easy Grinder is that their supervisors and their higher management is freed up. The people who do the daily grinding job sometimes don't rock up. Sometimes you can't even get hold of them. The quality has to be monitored. They have to be corrected on their quality, etc. And that is possibly one of the more interesting benefits of the system.
And I can imagine, because you cannot fire everyone, right, on the work. So you still have to hire some people, maybe to put the pallets inside of the robot cell, etc. But you say you need less people.
It's a lot more fun putting a pallet into a cell and pressing a button start than actually having to put the pallet next to yourself and lift the parts and grind them. So that's the one thing. But the other thing is also the job becomes a lot more interesting for the person who then gets partially freed.
And it's less heavy work, of course, yeah.
And to come back on your comment that you can't fire everybody, I don't think that's the biggest problem. We noticed that a lot of customers actually don't think that way. They see a problem where they can't even find people.
Mm-hmm.
So they're actually looking at expanding capacity or getting rid of a bottleneck, and the robot does that for them. So it adds capacity for people they can't find.
Yeah, and I can imagine it's a lot nicer to say at a party that you work with robots than that you're lifting very heavy metals and deburring manually all day.
Absolutely.
I can imagine that it's better to hire those people. Maybe to get we have another poll question. So what is your biggest challenge in your current manufacturing process? It would be very nice if we know if that would be labor cost, production efficiency, quality control, or others. And if it's others, you may put the answers in the chat. And as it might take a while before the answers come in, we have a lot of new questions in the chat. So let me ask those. Can this system be scaled to work in the area of 12 by 3 meters?
Yes.
Yes.
But
tell us.
you will need assisting handling equipment, which we have and we do offer. 12 meters is long. 3 by 12 is rather challenging. We'd be thinking along the lines of a somewhat larger robot than the 7600. No, 6700.
Yeah.
And we'd be thinking along the lines of what we call an easy transfer. And a multi-flipper on which we can traverse the part. Serious project. Shipbuilding and shipbuilders might be companies wanting something like this. So yes, but big project.
Yeah.
That will be time 2026.
Okay, and then in the meanwhile, I have the answers from the poll in the chat. So 0% says labor cost, 67 production efficiency, and 22% quality control. And then we have 11, so one answer in the other category, but I cannot see the answer for that. So most of the people say production efficiency. And that's an answer we love to hear, right?
Absolutely.
Makes
Sounds
sense.
good. Yeah.
And I saw that there were some other questions. Do you offer the solution as an off-the-shelf package? Can you advise an approximately cost of the solution?
We can, but it depends on a lot of factors. So the range is so big that we wouldn't be able to say anything worthwhile without knowing the specifics of the situation. So,
but you do work in modular blocks, right? So it's a standard solution.
Yeah, but the range is from 250,000 to 1 million, depending on everything you need. So there's a big range, and you can't say anything really worthwhile without
knowing more about it.
So they need to contact you.
They do.
Okay, and then what is the efficiency compared to a person?
Right.
Good question. Yeah, I'll tackle that one. The efficiency of the robot, it depends a little bit. If you break it down to the nitty gritty, then you could possibly say that on very small parts and smaller parts, a human is somewhat more efficient for a while until the day becomes long. On larger parts, the robot is simply more efficient. So the robot is faster, does the grinding faster, and has a better end result. And the robot is also faster if you have a lot of work you have to put into the part. So radius grinding or getting rid of the heat affected zone. That makes a big difference as well. Yeah, and another thing is that part of the efficiency can also be taken in a third shift. If you don't already run a third shift, you can run a robot into the third shift, which, for a human, you'd need another shift. Okay, and Frans, how does Techrom's technology ensure accuracy when removing burrs for complex parts, especially in industries that require high quality finishes? Okay, so high quality finishes means often that radius grinding, which you see a lot in the offshore or in the shipbuilding world or anywhere where they have higher coating requirements. It also means getting rid of the heat affected zone for some applications. Maybe roughening up the edges even. If a human were to do that the entire day, the human operator just gets tired, makes mistakes, oversees stuff. A robot works really consistently. So that's from a mechanical perspective. It has, let's say, endless energy and works consistently. But also the fact that we control the grinder tools perfectly. So if you look at the pressure we apply on the abrasive material, feed rates, the RPMs, we have the optimal mix. So you're getting a much more consistent process there. So I think it's that combination. The robot manipulator giving the consistent workload and the control of the grinder tools. Yeah.
And you can manage the whole process, right? You have all the data as well during the process. Yeah. And then what were the challenges that you faced developing the Easy Grinder?
I think that sums up to one word, and that is simply the variation. The variability and the variation that you have in the whole problem. Whether it's the variation in your geometry and not having to program, I mean, that's a pretty hard constraint. No programming, but any geometry. You've got the variation in which the parts get provided or presented to the robot, loosely stacked on a pallet, which you've got to deal with. You've got the variation of where your pallets are in the big wide world that you've got to contend with. You've got the variation of the burrs, the quality of the cuts that you've got to work with, the variation in the tolerances, especially if you look at flame cutting, for example, the tolerances can become quite wide, especially on the bigger parts. You've got a variation in the surface conditions of the part, whether it's a shiny part or whether it's a black part or a rusty part. You've got a lot of variation in the weight of the part. And then just outside just the geometry, so what the part looks like, physical size and how you hang on to that part, the variation in that brings a lot of challenges. So ultimately, I think in one word, variation is the big challenge.
Yeah, and it's a challenge you have overcome. So
yeah, but it's not something we knew up front.
You expected it to be easier?
Yeah, it should have been easier. Yeah.
But you managed anyway.
Yeah.
And how have companies benefited from using Techrom's Easy Grinder? Have they seen cost savings or faster production times?
I think they've benefited in a number of factors. They've freed up people to do other tasks which are more suitable for people rather than just the physical grinding. They've saved the costs of the man hours in that regard. They've saved on the supervision that they need to apply to the people that used to do the grinding. They've gained in the quality, consistency that they're getting out of it. They have an enormous saving in consumables because our robots deplete the consumables almost to nothing, whereas a human will use it up to 30%. A grinding disc will be used to 30%. So there are massive savings in that direction.
And just to add on to that, we have a customer in Germany who purchased 2 robots from us. And for a completely different reason than that list Roland already gave. And that's because he was about to lose his biggest customer because he couldn't fulfill his orders. And he couldn't find the right people.
Fulfill because of quality control. Capacity. Okay.
So the robots gave him the capacity to keep his customers. Which obviously is a worldwide thing now.
It is, I think, in metal.
So apart from just the savings, it also gives the benefit of being able to acquire turnover, which you might otherwise not be able to acquire.
Yeah, and if we look at the buzzwords these days, AI, how does AI contribute to the easy grinder? Did you applied it anyhow?
So that's a really difficult question because the definition of AI is a moving target. It keeps on moving. Once something is solved with AI, people forget that it's special, and then they don't call it AI anymore. So think about optical character recognition, one of the first AI applications. Nobody thinks that's special anymore. It's not called AI anymore. So it's a shifting target, and from that perspective, I'd say if you take a broad definition of AI, there's AI all over the place in the Easy Grinder and in all our solutions, or in many of our solutions. Not everybody would agree. So if you take a stricter definition, then it's especially in certain areas of our vision applications that AI is really relevant for us and will probably be a lot more relevant in the future as well. So there's a lot of potential there.
Yeah,
I think I can add to that a little bit. I think one definition of AI is when you ask the entity a question and you can't tell the difference of whether it's a human or whether it's a machine. That is then the ultimate AI. Now, we don't want that. We do. There are many aspects of the human we simply do not want in our machine, and it's simply not relevant in that regard at all.
Yeah, so, of course, you always have to choose what's relevant.
You want our machine to behave like a machine.
Yeah. I can imagine.
That can mean something slightly unfriendly, but after your comment on firing everybody, I think it's...
It's a very good webinar today. Okay, but let's take a quick look at the Easy Grinder in action. This video will give you a better idea of how the system works and how it automates the deburring and grinding process. Yeah, so we have another question in the chat. Finding employees to do grinding jobs over grinding so quality. We are in a remote area in the USA, so very dull, dirty, and dangerous job. I think that's
ideal
for you guys.
Absolutely.
So once again, contact Frans and contact Roland. And we'll have a chat about that later.
We have sold our first Easy Grinders to the United States. We have good local support. So we have a company called AFS who support us locally and supply the support customers need. So we're very well prepared to grow in the United States.
Yeah, that's good to know. It's always good to have someone locally as well when you're selling automation solutions. So what type of materials or parts are best suited for Techrom's Easy Grinder front?
We're really strong in sheet metal and plate parts, so oxyfuel, plasma cut parts, as Roland said, the high power laser cut parts. That's something we're really good at, and not only because of the software and the robotic solution, but also because we developed the grippers in-house. For a robotic application, grippers are really important, and we've got a really nice modular gripper family, which is very suited to those products. If you look at the sizes, generally from 150 millimeters by 150 millimeters all the way up to 4 meters by a meter. So there's the sweet spot is usually parts up to 200 kilos in part weight, but we can do more.
Yeah. And that depends also on the robot you put in the Easy Grinder machine,
yeah.
right? Yeah. So how easily can Techrom's Easy Grinder be added to existing production lines without causing major disruptions?
Very easily if you look at it as a replacement of what's happening now by hand. So if it's a replacement for the man grinding, it's trivial. You put in our cell, that's it. The rest of your operations you can maintain. If you're looking at it from a software integration point of view, certainly possible. We're open on all ends. We've got a strong background in business automation as well. So whether it's over OPC UA, networking, scripting, it doesn't really matter. We can interface over it. But those things typically become more of a project.
And more of a challenge probably when you want to interact with other different machines. They have to have an open interface as well, right?
Well, you've got to realize that part of our aim was actually to not have any integration at all. Remember, when you take a man and you put him on a grinding machine, for example, you tell him, listen, take these these parts and put them onto those machines, and on the other side it's going to come out and you've got to take it off. That's all the integration you need, and our robot was intended to do the same. So if we put our robots on a grinding machine, we don't need to interface with that machine at all, because vision does it. There are the pallets, and this is where I put it. And when it comes out, I can see the part, and I take it off, and I put it back on the pallet. What kind of integration do I need?
And it's the input for the next machine, and it works. The other machine works.
It knows how it has to pack the pallets because it sees how it gets the pallets. It's clever enough to understand that.
Yeah.
So we don't need to necessarily integrate. We can easily, and we've done it on long lines where you've got grinders and shot blasters and grinders integrated in one long line. If the customer wants us to drive that whole line, set it up to different thicknesses, etc., we do it easily. We've got a special protocol that we use over OPC UA, and we set up the line.
Yeah, so it is possible, but most of the times, if you just have the factory floor, you can put there the installation, the Easy Grinder.
We become the master of the cell. We can get our jobs from some other master of the entire system, and we command the cell, and the parts go in and the parts come out.
Yeah. Clear. And what customization options does Techrom offer to meet specific needs in different industries?
To start off with, it's important to emphasize we have standard solutions. So we have standard solutions for market segments. So the Easy Grinder, robotic grinding, handling solutions for different applications. So we think in standard solutions because there's a lot of technology involved and we don't want to do custom projects. We customize in a number of ways. One of them is obviously the cell layout, adapting it to the space available for the robotic solution.
I think we'd referred more to that as configuration. So we don't like to customize, but our building blocks, our Lego blocks are very configurable.
And if you look at our grippers, that's very much the case. Easy flippers to flip the parts. We can obviously select different robot manipulators. So there's a range of things we can do, but it's exactly as Roland said, it's configuring to customize.
Yeah, so it's easy to produce and easier for end customers to adapt to.
You see, one of the everything in our. You asked earlier what are the big challenges in this Easy Grinder, and I mentioned that it's variation and the variability that we come across. And what we found on this adventure is that the same applies for the customer. Every customer has his company geared and rigged in a particular kind of way. And if you're not configurable to fit in, it doesn't work. So our building blocks, as Frans mentioned, simply have to be building blocks, exactly that, so that we can plug them in such a manner that they as best possible suit the situation at the customers. But they're standard building blocks.
Yeah.
Sounds like a bit of a contradiction there, or maybe a paradox, but
no, but I understand it.
Yeah.
It's also the demand of the end customer, what they need, and maybe also the quality, how many products go through the easy grinder cell, etc.
Exactly.
To have the right application. Okay, and let me look, because there are a lot of questions, and that's very nice. So if you have more questions, please ask them in the chat. But why is the easy grinder solution using conventional tools? Why not industrial grinders like those from Mirka?
Yeah. It's a very good question. We get that question regularly. Personally, I think the choice for standard hand tools is one of the best choices we made. We often also get the question about customizing a certain spindle for the robot to maximize the use of, let's say, the strength the robot has. But we have a wide range of tools we can choose from now. There's a massive amount of tools available. They're quickly interchangeable. They're inexpensive.
Just jumping in there, the reason that having access to that wide variation is important is because you can then more specifically pick something that best fits the operation, the process that you need.
Yeah, so it's a question we regularly get. It's a good question. You never know what the future brings, but for now, we're really satisfied with what we can offer our customers. And also offer worldwide.
Correct. There's also another reason, and that is that one difference between a robot using these tools and a man using these tools, the breakage of the tools is very often not their usage. It's the dropping of the tool. It's the man handling of the tool. The robot doesn't have this problem. The robots, when these machines are depleted, when they are finished, actually we haven't actually seen a situation where that happens. Sometimes you do actually wear it out to the point that your brushes have to be replaced, or a gear has to be replaced, but the machine from the outside is still absolutely new. So the longevity of a good quality hand tool in the hands of a robot, to put it that way, is significantly higher than that of a man, and the typical doubts or reservations that somebody would have of taking a hand tool and putting it onto a robot.
That is an interesting insight.
We use the most powerful hand tools as well. So the hand tools are the heaviest, often the heaviest addition, which a human wouldn't like working with.
Mm-hmm.
And in some cases, like the chisel, we also, let's say, put it on steroids. So we have sensors in there, we have intelligence in there, so that the chisel can react to the resistance it feels. So for now, we think we made
It's a very clear answer, yeah. And we have a lot more questions, so I will go to the next question in the chat. And that is, how much is the solution presented in the video, the easy grinder approximately cost? So the video we just saw, it was the video you made in the factory itself. Someone really wants to know how much it costs. So
they can send us
send you all the questions afterwards. And then are they getting the positions of the parts only via 3D vision, or is there a match-up with the optimal 3D cut data?
The 3D vision does most of it. In fact, in most cases, it does all of it. But we are free, if we want to, for specific reasons, to load the CAD data.
And in what cases would you load the CAD data?
You would load the CAD data if the details of the part are such that the sensors cannot detect them. And then you simply have to know that some feature of the component is there.
So maybe in the future for past parts, that would be something where 3D data would be a must. We usually think 3D data is cheating. We want to work like a human works, hand-eye coordination, which in most cases does suffice.
Yeah, clear. And then, can the machine detect the wear of the consumables? If yes, how? For example, if a disc is no longer abrasive, can the machine detect this, or operator has to catch that?
No, the question is clear. It does not detect it. We found that we don't need that. Also not need the extra complexity of the sensors to detect that, which is not trivial. we found that due to the consistency of the process, the consistent pressure and the consistent movement, that we can quite accurately predict how long a consumable will last before it needs to be exchanged. So the robot tracks the usage, and it tells the operator it's time to change your disk, or it will switch over to a second reserve tool and then start using that if you want to run continue.
And a part of that predictability comes because of the fact that we chisel first. So we get rid of a lot of the stuff that causes bringing in the variability.
That causes in the variation, yeah.
Yeah. Okay, and how does using the Tecram Easy Grinder help companies to achieve a good return on investment, ROI, both in short and long term?
Well, the first one is the saving in man hours. The second one is the higher output, compared to the man outright. The third one is the saving in effort that your management has to put into it. Fourth one is your consumables that pays itself back. And then you mustn't forget that if you do an investment like that, and let's say you earn it back in 2, 3, 4, 5 years, it depends on how many shifts you run. After that, an ABB robot, many robots even, but ABB maybe in particular, can run for 20, 25 years. And after the amortization period, you're operating for €1 an hour. Now, how do you beat that?
Yeah, I would not work for €1 an hour. That's for sure.
To emphasize the same point again, that's purely your ROI from, let's say, hard financial perspective. The biggest upside can be the capacity you can add to your production, which you cannot find at the moment. So just being able to sell more, what does that do for your top line?
Well, what about your quality? We've got customers for whom that the quality requirements was so important, because of their customers again, that just simply doing it with humans was simply kept on bringing back returns. This again, it's hard to quantify what that does for your bottom line, but it certainly affects the ROI.
Yeah. Okay, then we have another poll question. How likely are you to consider automating your grinding and deburring process in the next 1 to 2 years? Very likely, somewhat likely, or not likely. And then, in the meanwhile, we'll look at a video. Let's have a look at the behind the scenes of the Tecram's factory. The video will show you where the Easy Grinder and other solutions are developed and tested. And we're back. Let's start with another poll question, with another question in the chat. How thin of material, primarily in 304 stainless, can you load and unload on a deburring machine? Do you need an example for that? Or
No, that's clear. If you want to load a deburring machine, we'd say from 2 millimeters and up. So for the thinner material, we have special grippers. So we'd say 2 millimeters and up.
Okay, clear. And then we have a new guest in the studio. And thank you very much, Martin Visser, for joining the table. You started working at ABB Robotics in 1991. So you have a lot of experience, and especially in metal applications, right?
Yes, that's right. I started in 91. It was a long time ago. I did a lot in metal fabrication, welding, cutting, service, sales, everything.
Yeah, the world has changed in the meanwhile, that's for sure. Yes. And if we're curious, I'm very curious what the poll answers will be. Huh? So if people are likely to invest in a deburring process in the next 1 to 2 years, we have 58% very likely, 25% somewhat likely, and 70% not likely. So I think that's a very good answer for us for today. Thank you very much for interacting. And if you have more questions, please ask them in the chat, because it's very nice to answer your questions. And then, Martin, what was your role in helping Tecram develop the Easy Grinder?
I I think it was in 2016 you started with development the EC grinder. I was involved from 21, and I did a lot of. I was the first point of contact. Help them with quotations, with technical questions. We did training. We did a lot to help TechRam to development of that grinder.
Okay, and Frans, why did TechRam or you chose to work with ABB as a partner?
It's a decision we didn't take lightly at the time. So we looked at a number of, let's say, robot suppliers, and there are a number of things ABB offered which were interesting to us. One of them is a wide range of robotic manipulators. So it's nowadays also the cobots, but all the way up to the heavy-duty XXL robots. That's a big range. So that was important to us. We like the fact that the ABB robots have a very high torque on axis 5 and axis 6. We think that's a big plus. Mm-hmm. Path accuracy is important, something ABB is really good at. And open controller. So obviously our software needs to speak to the robot, and that's something that the ABB systems do very well.
Yeah, our rapid program of rapid code is very open. You can make your own code, your own instructions. It's a completely open platform. We're proud of that.
That's good to hear, of course, as an ABB robotics employee. And Martin, how do TechRam robots handle variations in parts like shapes and sizes? We already talked about it a bit before, but maybe you can explain a bit more.
Yes, TechRam use 3 types of our robots. The 6700 in 2 types, 155 kilo and the 245 kilo with a reach of 3 meters. And then we have the 8700 and there's a range of more than 4 meters. And TechRam used this robot in reverse down, so you can pick up parts of 600 kilo. With to the long arm, you can have parts of 4 meters long.
That's pretty long and pretty heavy as well. And maybe it's an opposite question to the one in the chat, because they're curious if you can also work with a GOFA.
We can, yes.
You can. Explain a bit more about that.
Well, we are playing around with the GOFA already. So we've got 2 GOFAs we're working with. We haven't got a customer application yet, but you never know. But in principle, there's no reason why we can't work with any of the ABB robots.
And a GOFA, you choose to look at the field of a GOFA so that it can interact with humans, or?
Yes, but if you ask me, I see one of the big advantages of the cobots is that they're really light. So you can position them in completely other ways than the industrial robots. They do have disadvantages, but generally there's a lot more you need to get your CE. And the difference between a cobot and an industrial robot for our applications is, up to now, negligible. So, but we are experimenting with them, and we have some nice things going on.
Good to hear.
Yeah.
And how is ABB Robotics preparing for the future, Martin? Especially with the growing role of AI and machine learning in automation, of course.
Yeah, that's a good question. At this moment, we're building a new factory plant in Västerås in Sweden to extend our production of all the robot types. We already launched a new controller called Omnicore. And the Omnicore platform, we have 5 controllers for the Omnicore platform. A bigger computer, more power to do AI, all the processes. So we are prepared for the future. And also cyber security is also included in the new controller. So we have a nice controller who is ready for the future.
And where we're talking about the future, Frans, I'm very curious if you're looking ahead. What's your vision for the upcoming 5 years?
At the moment, we've got a very good product market combination. So we have good solutions for robotic grinding, Easy Grinder, obviously, we have good solutions for loading and unloading deburring machines, shot blasting machines, leveling machines, laser automation, so loading plates and unloading them with a robot. So there's a number of really attractive applications where we've got in the field at the moment. But Techram was founded to do stuff which hasn't been automated. So our solutions are quite unique from that perspective, and our main competitor is the traditional way of doing stuff. So a guy with a crane or an operator with a grinding tool. And if we really, really want to make a difference, then our main objective in the next 4 or 5 years is more speed. So obviously that's mainly software. Good thing is that our existing customers will also get the upgrade and will also speed up in the next 4 or 5 years. The other one is more flexibility. So that variation Roland was speaking about is making sure that we can deal with ever more variation. So more variation, more flexibility, more speed. That's what we want to do in the next few years.
Sounds good. Sounds great. The sky's the limit. So if there are challenges in the market, they can challenge Techram then.
Absolutely.
Yeah. We have a few more questions in the chat. How well the system can handle deviation of flatness on the plate. EU standards allow the plate producers up to 8 millimeters of flatness deviation. Can the system detect that variation? Depth variation, sorry.
The system can detect depth variation, but we actually have a really creative way of dealing with that, and that's actually with our, let's say, control mechanism of the tools. So we have some leeway in how our tools, maybe in the videos the viewers saw actually how our grinding tools are hinged, and that gives us a lot of leeway. So the fact that the material isn't always straight is something which is not too great of an issue for us.
Okay, and then another question. How well the system reacts to light changes in a working area, such as welding light flashing on the part, or a door opening, dust variation in the area, etc.?
All of our systems run in industrial environments. So overhead cranes moving across lights is something which could be an issue. In general, we say if it's a normal factory environment and you don't have direct sunlight in the range of the robot, you should be okay. If there's direct sunlight, it breaks everything.
Yeah, but that's because of reflection, right? And vision, yeah.
It's direct sunlight is a big thing. But there are, let's say, vision experts who say vision is about controlling the light environment. From that perspective, we have a really robust system, which is industrial grade and works in normal factory circumstances.
Yeah. Okay. And then there is another question. What is the force compliance technology used for the Easy Grinder? And how is the right abrasive and operating parameters, force, RPM, etc., chosen for the application depending on removal and surface finish need?
Okay, I'll start with the abrasive question first. The suppliers of the abrasive material have optimum specs. So we try to follow those specs. From a feed rate perspective, pressure perspective, that's something we get from them and we put into the parameters in our system. Regarding the other question, which is, let's say, how we deal with force, we have a patented system, patented control mechanism, which and that's again that hinge mechanism in combination with the encoder to measure actually what the angle is, which takes care of that. So we don't use force control from that perspective. We have our own system.
I see that we're running out of time. So if there are any more questions, please ask them and we will answer them afterwards. And that brings us to the end of the webinar today. I hope we were able to answer all of your questions. And if not, please ask them and we'll answer them afterwards to give you a clear insight on the power of Techram's Easy Grinder. A special thanks to Martin Visser, Frans Tollenaar and Roland Tollenaar, who were the experts of today. And if you want to explore Techram's solution and how it can be integrated into your production line, feel free to reach out to us after the webinar. We also share a recording of the session so you can watch it back later. And if you're in the neighborhood, TechCrom will be at the Euroblech in Hanover, October 22nd till the 25th. So we hope to see you there. And thank you all for attending this webinar.